Good day, everyone. I am Normina Mola and I am tasked to discuss other standard scores. In this video discussion, I will first discuss STENINE, then a brief discussion of Scholastic Aptitude Test or the SAT and the Graduate Record Examination will follow, as well as IQ scores. Next is the two types of conversion of standard scores, the linear and nonlinear transformation. And then last is the normalized standard scores. At the end of my discussion, you are expected to identify other standard scores aside from Z-score and T-scores, and also identify the two types of conversion of standard scores. So without further ado, let's begin. Aside from the Z-scores and the T-scores, there are numerous standard scoring systems that exist. First, we have STENINE, a term derived from contraction of the word standard and nine. It is a standard score developed by researchers during the World War II with a mean of 5 and a standard deviation of approximately 2. It is a normal curve divided into 9 units. One example of STENINE is the achievement tests administered in elementary and secondary school, wherein the scores of tests are often represented as 9. So as you can see in this figure, one of its distinguished characteristics is that they take on whole values from 1 to 9 that represent range of performance that is half of a standard deviation in width. The fifth stanine equates to the average performance and captures the middle 20% of the scores in a normal distribution, while the fourth and the sixth stanines captures the 17% of cases below and above the fifth stanine respectively. The area under stanine's fourth, fifth, and sixth represents an average performance, while the areas under first, second, and third stanines hold a performance value of below average, and the areas under stanines seventh, eighth, and ninth equates to an above average performance. So another type of standard score is employed on tests such as the Scholastic Aptitude Test, SAT, and the Graduate Record Examination or GRE. So both standard scores have a mean of 500 and a standard deviation of 100. Row scores on of such tests are converted to standard scores. Say for instance, if the letter A is used to represent a standard score from a college admission test whose distribution has a mean of 500 and a standard deviation of 100, then this expression is true. Another example of standard score is the IQ score, where the distribution of raw scores of most IQ tests is converted to. So, I believe everyone's familiar or at least have heard what IQ is, but not everyone, including me, knows that it is yet another kind of standard score. The distribution of IQ score typically has a mean set of 100 and a standard deviation set at 15. So note the word typically, okay, because there is some variation in standard scoring systems depending on what test is used. So in this figure, we can see the corresponding equivalent or relationship of Z scores, T scores, and IQ scores, as well as the A scores representing the SAT and the GRE. So remember this expression. We can see this in this area of this standard normal curve. The value of A is 600, which equates to 60 of T scores and 1 in Z scores. So of course, the value in the center of the curve is the mean of each standard score, and with the standard deviation of each respectively, we derive the value on the left and on the right side of the normal curve. So moving on, there are two types of conversion of raw scores into standard scores. we have the linear transformation and the nonlinear transformation. Take note that when a standard score obtained retains a direct numerical relationship to the original raw score, a linear transformation is involved. The difference between corresponding raw scores is paralleled by the magnitude of differences between the standard scores. Say for instance, the creators of the SAT did a second linear transformation on their data to convert z-scores into a new scale that has a mean of 500 and a standard deviation of 100. Just like this expression. When the data under consideration are not normally distributed yet comparisons with normal distributions is needed, or when the resulting standard score does not necessarily have a direct relationship to the raw score, then a nonlinear transformation is required. As the result of nonlinear transformation, the original distribution is said to have been normalized. So how is the original distribution being normalized? There are some instances where even after testing very large samples with an instrument under development, the test yields a skewed distribution results. So as an alternative, test developers normalizes the distribution. They stretch the skewed curve into the shape of normal curve, a process called normalizing a distribution, which creates a corresponding scale of standard scores, technically referred to as a normalized standard score scale. Normalization of a skewed distribution of scores may also be desirable for purposes of comparability, because comparison would be inappropriate when the distributions from which they are derived are not the same. So it is clear that one of the primary benefits or advantages of a standard score on one test is that it can readily be compared with a standard score on another test.